Okay, so this video is meant for my Algebra 2 students who come from CVCC every day. We do have a test, two-part test, Tuesday and Wednesday. And again, it'll be very similar both days, just different problems. Different problems over the same material. So let's start off with some factoring review questions, okay? So we need to factor each of these. All right. So let's take a look at the first one. 6x cubed plus 17x squared plus 5x. Well, whenever you factor, first thing you always like to do is pull out a common factor. Well, notice all of them have an x. Let's pull out one x, right? You pull out the lowest power. So this is going to be 6x, that brings it down to a squared, plus 17x, takes away the squared because you only have one x, plus 5, and that x disappears. Now this is a trinomial, so let's factor it with our two parentheses. All right. C is positive, so that means the same sign. So look at your B, positive and positive. To get x squared, I need an x and an x. And now we have two numbers to look at. We look at A, which is 6. And it has two sets of factors, 1 and 6 and 2 and 3. C, which is 5, have one set of factors, 1 and 5. So I know I must use 1 and 5. So I'm going to put a times 1 here and a times 5 there. So since my signs are the same, whatever products I get, I'm going to add to get 17. Well, I know that 3 times 5 is 15. So let's choose 3 and 5. 3 with the 2, or I'm sorry, 3 with the 5, 2 with the 1. This is 2 and 15. Our signs are both positive, so plus plus, that's a positive 17. So there we go. So this is the correct assortment of numbers. So what we're going to do is we're going to place the second numbers first, the 1 and the 5. They both follow plus signs, so it does not matter where they go. 1 here, 5 there. Now, I put the 1 in the inside, so the 2 has to also go in the inside, right there. I put the 5 on the outside, so the 3 has to go on the outside, right there. And here is your factored form. X times 3x plus 1 times 2x plus 5. Common factor. So if you want to write over here, common factor was x. Always look for a common factor. Okay, B. B has two terms, and I look at 9 and 1, I say perfect squares. This is 3x squared. This is 1 squared. So remember, it factors into your two sets of parentheses. One's plus and one's minus, and it's just those terms, 3x plus 1, 3x minus 1. Difference of perfect squares. Okay, C. Again, two terms, but now we have cubes, like x cubed, and it's a sum. Well, that's okay. If these are perfect cubes, we can write it as a sum of perfect cubes. Well, 125 is 5, and x cubed is x cubed, so that's 5x cubed. 64 is 4 cubed. So remember a difference of perfect cubes, and I'll give you a sum or difference of perfect cubes, and I'll give you the formula on the test. But the first parenthesis is exactly what it says without the cubes. 5x plus 4. Exactly what it says. Then we square the first term. So if you want to look here, we square 5x, and we get 25x squared. Then we choose the opposite sign. If you remember SOAP, same opposite, and the AP will be here, SOAP. So the middle sign is always opposite of what you were given. So this is the product of your two terms, 5x times 4, which is 20x. The last is AP, always positive, and it's the second term squared, 4 squared, which is 16. And there's your factored form. Sum or difference of perfect cubes. And the last one, this is a 4-term expression. It is going to be factored by grouping. Remember, factored by grouping. First terms, second two terms. What's common? I see it x squared. That leaves me with an x, and I took the whole thing away, so I have to put a plus 1 in its place. Bring down that middle sign, minus. We're going to pull a 16 out. Notice we're pulling out a negative 16, so your signs switch. So negative 16x becomes x, and negative 16, when you pull the entire thing out, positive 1. See this repeating factor of x plus 1? Pull that way out in front and cross it off. It's gone. The second parenthesis has what's left over, x squared minus 16. I don't think I'm done because x squared minus 16 is a perfect square, right? X squared and 4 squared, and it's a difference. So we have x plus 1, which stays the same. But then this becomes x minus 4, x plus 4. And there's your full factored form. So make sure you know all the different methods of factoring. Okay, here's our next one. And this is a problem that we really haven't done exactly before, but we've talked all about it. This one says find the x-intercepts. And here's my graph. Here's my equation. Y equals 5x squared plus 3x minus 2. Well, to do this problem, you need to know what it means to be an x-intercept. Remember, these parabolas, right? If they go through the x-axis, they're going to have x-intercepts right here and here. Every x-intercept has some number for its x, but then its y is always 0. So all we're going to do here is we're going to take out y and put 0 in its place. That's all we're going to do. And it's going to look like this problem. 5x squared plus 3x minus 2 equals 0. Okay? All right. So this is the problem we're going to do. Now, I'm going to first find the discriminant to see if this is a nice problem. I suspect it's going to factor, but I don't know for sure. Okay? So we'll take b squared minus 4 times a times c. b squared minus 4ac. Okay? And again, we just use our calculator, and we get 49. Make sure you put that 3 in parentheses. But this comes out to be 49, and we say this is the perfect square, so I can factor it. Now, you can go ahead and use the quadratic formula. I don't care, but I'm going to factor this one, all right? So if I look here, there is no common factor, so I use my 2 sets of parentheses. C is negative, which means different signs. To get x squared, I need x and x. And now I look at my 2 numbers. 5, which is 1 and 5, got to use them. And 2, which is 1 and 2, got to use them. Now, I need a difference of 3 in the middle. Well, I already know that 2 and 5 have a difference of 3. So don't put them together because that would be 10, right? 5 times 2 is 10. Put them away from each other. 2 here, 1 there. That gets me 2. That gets me 5. I want a plus 3 in the middle. So 5 must be positive. 2 is negative. There, that's what gives me my positive 3. So I transfer that up here, and I'm going to put my C numbers in first. 2 has to go behind the negative. 1 has to go behind the positive. Now, I put the 2 on the outside. This 1 has to be multiplied with the 2. Put it on the outside. I put this 1 in the inside. This 5 has to be multiplied with it. Put it on the inside. There's the factored form. Now, the difference is here is you have this equals 0. Remember, this equals 0, so we must find the 2 numbers by taking our parentheses and setting them equal to 0. So we'll subtract 1 here and get x equals negative 1. We'll do 2 steps here. We'll add 2 and divide by 5, and we'll get 2/5 there. So to answer this question, your x-intercepts truly are the points -1, 0, and 2/5, 0. So again, just to emphasize this some more, so on the graph, right? -1, 0, and 2/5. So that's a little bit before 1, right? So, and since this A is positive, this graph's can open up. So your graph looks like this, something like that. Okay. So here's how you find the x-intercept. So let y be 0. All right, our next problem. Solve by completing the square, right? This process of completing the square. All right. And we're going to leave our answers in simplified radical form if possible. So no calculator here. All right. So it's a process, right? First thing we do is we only care about the things with x's. So we're going to add the 10 to both sides. 2x squared plus 8x equals 10. Now, the next thing is, and this is very important, you cannot complete the square until x squared has just x squared. Not 2x squareds, just 1x squared. So we must take everything, and because, remember, there's problems with y, there's problems without y. This problem does not have y in it, so we can go ahead and divide everything by 2. Divide everything by 2. 1, 2, 3 things. X squared plus 4x equals 5. And now we're going to complete the square. To complete the square, remember, you're going to add something to both sides. You're going to add half of b squared. B is 4. Take half of b and square it. and that gets added to both sides. Added 5 plus half of b squared. Okay, so this becomes x squared plus 4x. Half of 4 is 2, 2 squared is 4. So I added 4 to both sides. Now, on the left side, this needs to be written as something squared. Now I'm going to put it up here, okay? Whenever you do that, it's x plus b over 2 squared. That's what it becomes. Once you find that c that makes it a perfect square trinomial, it's x plus b over 2. So my b over 2 here was 4 over 2. 4 over 2 is 2. So 4 over 2 is 2. That's what goes in there, the 2. You get a 9 on this side. I don't want this squared, so I take the square root. Take the square root. When I take the square root of a number, plus or minus, I get x plus 2 equals, this square root simplifies, right? It's 3 squared, so 3 comes out. And when I subtract 2, what happens is I get x equals, the negative 2 goes in front of the plus or minus 3. And this, you need to tell me the two answers. You must tell me these two answers. So we split it apart into negative 2 plus 3, and negative 2 minus 3. So my two x values are 1 and negative 5. X equals 1, x equals negative 5. Now notice that these are rational solutions. So up here, this must have been a factorable quadratic. All right? But here's the complete and the square to solve an equation. Okay, here's our next problem. This problem says, it's going to say right, I put in vertex form. Vertex form, all right? Now, remember, vertex form looks like this. Y equals a parenthesis x minus h squared plus k, where the vertex is at hk. We need to write this guy like this. Well, notice this x minus h squared looks very similar to the problem we just did, so I think we need to complete the square. Okay, so we're going to complete the square here. Again, I only care about the x terms, so get rid of this 5. So we get y plus 5 equals 2x squared minus 12x. Okay, so we get rid of that 5. Now, we can't complete the square until x squared is by itself, right? We don't want 2 of them, we just want 1 of them. But we have this y, so we can't divide everything by 2, so we must pull out the 2. We pull it out. We pull it out just like so. All right? So 2x squared minus 12x becomes 2 parentheses x squared minus 6x. And now we complete the square. We're going to add something. I'm going to leave a space. 2 parentheses x squared minus 6x. Remember, we're going to add b over 2 squared. Now, remember what I taught you guys. When you pull something out, think about distribution. You didn't just add b over 2 squared. You added 2 times b over 2 squared. That's what you added. All right? So this becomes negative 3 squared, which is 9, and 2 times 9, which is 18. So this is plus 18. Notice the negative when you square it becomes positive. Equals 2 parentheses x squared minus 6x. And this is not 18. This is negative 3 squared, which is 9. But think, if I were to distribute, right, 2 times 9 is 18. That's where that 18 comes from. Okay? So be careful. So we just simplify. Y plus 23 equals 2 times, and now here's that x, b over 2 squared. b over 2 was negative 6 over 2, negative 3. Negative 6 over 2 is negative 3. Remember, x plus b over 2 squared. If your b over 2 is negative, then that becomes a negative sign, and that's what happens here. b over 2 is negative. And then we don't want to solve here. We want to get y by itself because we want to put it in this vertex form. So we subtract 23 to get y alone. Y equals 2 parentheses x minus 3 squared minus 23. There's your vertex form, and your vertex is at the opposite of h. So this has negative 3, so it's at positive 3, and the same as k. And there's the vertex. Okay. I'm going to create another video talking mostly about the quadratic formula and inequality, so make sure you watch that one as well.